Welcome everyone to the session ArcGIS Runtime SDK for Android, Building Apps.
So welcome to this session where we're going to be introducing the ArcGIS Runtime SDK for Java. I'm Mark Baird and I'm joined by my colleagues Jen Merritt and Simone Claridge, and we're all engineers on the Runtime SDK for Java team. What we're going to do here is taking you through the process of writing your own map-based desktop application. So this is going to be using the latest version of Runtime, which is version 100.10, and we're going to be building up a Java 11 and JavaFX application. I'll introduce you to a new concept for accessing ArcGIS Online resources. This is called API keys, and I'll also take you through key concepts and classes that you'll be working with to build up your own application. So this will include maps and base maps and graphics overlays. I'll spend a little bit of time talking about offline capabilities for working with data when you don't have any network connection. And we'll finish up with licensing and deployment so you can make your applications go to market. So if you've not used Runtime before, the best place to get started is to go to our developers website, developers.arcgis.com. So I'm just going to switch over to that and I'll give you a guided tour. So here we have developers.arcgis.com, and if I just click on the documentation tab and I'll scroll down past web APIs to mobile and desktop APIs, and we're interested in runtime applications for Java. So here we have the landing page for the Java product, and this has got a large number of tutorials and concept documentation to explain how you can embed specific GIS and mapping functionality into your own applications. So we've got a get started guide here, what we'll be taking you through in a moment, and then there's specific instructions for performing tasks like adding routing or directions into your application. Now, to complement these tutorials and concept docs, we've got some sample code which is available in a GitHub repository. So here we have a large number of self-contained applications that demonstrate how to put these areas of functionality into your own applications, and the source code is available here for you to pull and run inside your IDE. Now, if you want to experience the capabilities of Runtime without actually looking at an IDE, you can download our sample viewer application, which demonstrates all of the capabilities without using an IDE. And we've got our API reference here, which of course you can embed inside your IDE. And if you get stuck, there's a support page here, which contains a link to our GeoNet forum. So if you've got any questions, you can go ahead and ask us on it there. So the SDK is available in one of two ways. You can go to our download site and get a hold of the zip or the tarred gunzip file, which contains all the files that you can put into your own IDE. But more commonly, people will be making use of the Maven repository that we have, so you can download the files and reference them inside a Gradle or a Maven scripting environment. So the SDK is based upon Java 11, but we're keeping a very close eye on Java 17, which is coming out soon, making sure that we fully support that. We don't support Java 8, and in fact, the last version of Runtime we supported Java 8 is going back now to 100.4, so all releases are Java 11 at the moment. Now, of course, you could choose the Java runtime environment that you execute your applications in. So we make use of the adopt OpenJDK, but of course you can make use of OpenJDK or Oracle's JDK too, and we do test against all of those. So let's go and take a look at the API keys. So API keys have been introduced to authenticate your application to access ArcGIS platform services. So this includes things like base maps or geocoding services or routing services, for example. Now, it's worth saying that you don't need an API key if you're making use of your own data or services. This is just for accessing ArcGIS Online services. And of course, the API keys are available for runtime applications to use, but also for the other APIs too. So you'd use an API key if you're using exactly the same services in a JavaScript application, for example. And you can also make use of them if you're writing applications using other mapping technologies from Leaflet or Mapbox, for example. Now these are created through the developer side dashboard. So let's just switch over to my dashboard. So going from my Java page here, I'm just going to click on dashboard. And you can see here that I don't have any API keys yet in my dashboard, so I'm going to create one here. So I'm just going to give it a name and create the API key. So here I have the key. Now I can configure the service capabilities here to find out what capabilities that it has, whether it has routing or geocoding, for example. And then once I've done that, I can copy the key. And in this case, I'm going to Slack that to Jen and Simone so we can include that in the application that we're writing. Okay, so we're going to take a look now at some of the classes and the concepts around writing your own runtime application. So the most common workflow is for developers to write 2D applications, and when you're doing this you'll be working with two key classes. Now the first of which is the map view, which is a JavaFX component that you'll put inside your application or your FXML layout, for example. And this is the control that you'll use for visualizing and interacting with your data, like zooming in and zooming out, for example. Now the contents of the data inside the map view is defined inside the ArcGIS map class, and this class is for defining the base map, so the wallpaper that you're going to be displaying in your application, and then of course there's your own business data, your operational layers, your points, lines and polygons that you'll display for your own apps. So what I'm going to do now is hand you over to Simone, who's going to give you a demonstration of writing a basic 2D application.
Thanks, Mark. Now, before we jump into the code here, we just want to show you the application we'll be building. Here we have a simple 2D map with an imagery base map. Now, the code that we'll be working with is pulled from our Java Gradle Starter project, which you can currently access up on GitHub. Now, if we take a look here, the first step we want to do is set up some JavaFX application code. Here we set the width and height on the JavaFX stage and show the stage on the screen. The next step here is to create a stack pane and a scene and set the scene to the stage. Next step here is we want to set our API key to the ArcGIS Runtime environment. As Mark mentioned earlier, the API key will allow us to access Esri location services, including base map layers used in our application today. Next step here is we want to create a new map view. Now, the map view acts as a container for our map. We can then add the map view to the JavaFX stack pane so that the map will be shown within our application. Next step here is we want to create a new ArcGIS map with the base map style of our choice. Today we'll be using the imagery base map. And finally, we want to set the map to the map view. And we can just run our application here. And here we have it. A 2D map with the imagery base map. Over to you, Mark.
Thanks, Simone. So as you can see, writing 2D applications is really straightforward using the map view and the map class. You can go a little bit further and visualize your data in 3D very easily too. So rather than working with a map view and a map, you'll be working with a scene view and a scene. So the scene view is the JavaFX control that you will put inside your JavaFX application for visualizing and interacting with your data, zooming in, zooming out and changing the camera position. And the data that you're creating and visualizing inside your scene view is defined inside the ArcGIS scene class. Now this is very similar to a map, so as you can see it's got a base map and operational layers for your own business data, but also we have the concept of a surface, and what a surface does is it brings in a terrain so you can visualize the lumps and bumps that make up a mountain range, for example. So to demonstrate this, I'm going to hand you over now to Jen, who's going to show you a 3D application from our sample viewer.
Thanks, Mark. So as well as the starter project that Simone just demonstrated, there's also our Java samples repository, which has various other apps that you can have a play with. And I've cloned the repository, and I'm going to use the display scene sample to demonstrate how to create a simple 3D application. So I have the app running here, and you can see that the base map is similar to the 2D application, but the key difference is that we can clearly see the terrain of the mountains, and I'll explain how we achieve this by taking a look at the code. So much like in the 2D application that used a map view and ArcGIS map class, we create an ArcGIS scene with a base map and set that to a scene view. And the additional concept here with scenes is that of a surface, and the surface is effectively what displays the terrain. So we input an elevation source, and we then set this as the base surface on the scene. And if I just go back to the running application, again you can see the terrain here and the different varying elevations across this mountain range as I pan and zoom around. And that's back to you, Mark.
Thanks, Jen. So as you've seen, writing 3D visualization applications is just as easy as writing 2D apps. We're working with the scene and the scene view in this case. Now, until now, the applications that we've been created in 2D and 3D have only been displaying base maps or surfaces. You want to build up on those so that they're displaying your own business data. So you've seen with both the map and the scene classes, we've got this operational layers collection, and this is where you're going to add in your business data. And this can be representative of points, lines, polygons, text attributes, file attachments, photographs, all of that data that brings your application to life. Now, the data can come from local file formats that you may have stored on your local hard disk. So these could be geopackages or shapefiles or raster data, for example. But more commonly, you're going to be making use of server sources for your data as a single source of truth. Now, this data could be coming from ArcGIS Online or your own instance of ArcGIS Server, or we also have support for a number of the OGC open data formats like WFS, for example. Now, to demonstrate bringing in your own data, I'm going to hand you back now to Simone, who's going to extend upon the application that she started working on earlier.
Thanks, Mark. In this demo, I will show you how to add this hosted feature layer of hiking trails as an operational layer to our ArcGIS map. Now, in our app here, we've gone ahead and created a map with a topographic base map. We've created a new map view as a container for our map, and we've set the map to the map view. Now, from here, we can create a service feature table with a URL of a feature service of hiking trails, which is currently hosted on ArcGIS Online. The data from the service feature table is then used to create a feature layer. And from there, we can add the feature layer as an operational layer to our map to bring our data into the application. Now, from there, we can set a viewpoint so that the map opens on our feature layer at a specific latitude and longitude. Finally, we add our map view to the JavaFX stack pane so we can see our map within our application. Now let's run our app so that we can see our data on the map. And there we have it. We've got our hiking trails on our map. Now this is great, but let's say we ran into a problem where we lost network connection when we were running this app. So to test this out, I'm just going to break this URL, and we'll see what happens when we run the app again. So it looks like the map has loaded, but we don't have our feature layer, and we're not sure what the problem is. It looks like it's failed silently, and we'd like to know what has happened here. So I'll pass it over back to Mark, and he'll explain what we can do about this.
Thanks, Simone. So, what are we going to do about this silent failure we have in this application? Well, the answer is it's to listen in to the loadable pattern. And the loadable pattern is an asynchronous programming pattern that we've implemented right across the Runtime SDK. And it's especially useful for working with network resources, for example. So network resources, sometimes they can respond instantaneously, and then sometimes they don't because the network's slow. And one thing we don't want to do when we're working with applications is to hold up or block the UI thread when we're waiting for something to happen. So we need to asynchronously listen in to these event changes. So in the example of the service that we're working with here, when we first create the class, it's going to be in not loaded state. And then as the service starts to communicate with the backend server to get its metadata or its associated capabilities, it'll be in the loading state. And then once we've got successful communications with it and we're happy that it's working, it'll fall into the loaded state. And we can listen into this to switch on UI components associated with editing the data, for example. Or if something goes wrong whilst it's loading and we don't actually get a response from the server, we can put it into and listen in to the failed to load status. And these can be used for displaying an error message on the screen, for example. So to demonstrate how we wire this up for the service that Simone has, I'm going to hand you back so we can show you the code.
Thanks, Mark. Here we have the same code as the previous demo. We have our broken URL for the feature service of hiking trails, but this time we've added a loading listener to our feature layer. So now when the feature layer is created, the loading process starts. We can specify code that will happen on a new thread asynchronously once the feature layer has finished loading. So here we can check that the feature layer has successfully loaded, and we can print out the load status to the user in the console. If the feature layer fails to load, we can show the loading error in an alert to the user to let the user know what has gone wrong. So if we run the application again, we can see here that the feature layer has failed to load, which is expected, but now we have a message and we can now know what to do about that. Now if we go back to the URL and fix this up and run the application again, we can see our data has been successfully added to the map, and we've got the load message, the load status, printed off to the user. And so knowing the load statuses of the data is really powerful because now we can programmatically enable any user interface controls, such as an editing toolbar in our application, once the layer has successfully loaded. And with that, I'll hand it back over to Mark.
Thanks, Simone. So as you can see, by implementing and listening in to the loadable pattern, we've made our application much more robust and it can give some good feedback as to whether things are going well or not so well in our application, and we can give our users that all-important UI feedback. Now, in all the applications we've been working on so far, we've been programmatically defining the contents of the data that we're going to display inside our map. So we've been specifying the base map and loading the operational layers. Now, there is a slightly easier approach potentially to this. This is where you can use ArcGIS Online or your own portal to predefine these web maps. So using ArcGIS Online, for example, you can design yourself a map looking at the base map and the operational layers and the cartography that you want to use to visualize that, and you can save that map. So inside your runtime application, you can then log into the portal, you can seek out this web map and then just populate it from that portal item. And then all of that design, the cartography and the layers that you've designed in ArcGIS Online can be automatically brought into your runtime application, so it can be visualized in exactly the same way as it might do in another client, like a JavaScript application, for example. So what I'm going to do now is hand you over to Jen, who's got a web map that she's going to show and bring into a runtime application.
Thanks, Mark. So I'm logged into my ArcGIS Online account, and in here I've got a web map that I've created, and this is the item information page. So if I click through to open this web map in the map viewer, then we'll see the map open up. And it's set to zoom in onto a village in the UK. And we can see we've got an open street base map here that shows details such as footpaths and buildings. And on top of that, we've got a layer with some custom numbered symbols displaying various points of interest. And if I click on one of the points here, then some more information is displayed in a pop-up. And we've got a sort of title and description. So Mark introduced the idea that we can, rather than creating this map from scratch again, instead use a portal item to use the web map in a runtime application. So if I just move into my Java code here, firstly what I need to do is to create a portal, and this references ArcGIS Online here, which is where my web map is hosted. And then in order to finish creating our portal item, we need a portal item ID. So if I just hop back to ArcGIS Online, then I can get the portal item ID from the URL here. And if I just copy that across into my application, then we've got the portal item here with the portal item ID. And finally, we then set that to our ArcGIS map. And then set that in turn to the map view. And finally then, when we run our application, once that loads, we'll see the same map that we saw when we were working within ArcGIS Online, and we have the same base map and the same symbology as well here. There is a few extra steps that you can do to configure the pop-ups or any other UI elements that are appropriate for the platform, such as here in the JavaFX UI where these callouts have been created. But the data itself, so again the sort of title and description, is taken from the web map. And as well as a Java desktop application, I could also create a mobile application, or I've also got an example here of a JavaScript web app, which again uses the web map and makes use of that item ID to access the different information, such as the title and description again that's being used here. And that's back to Mark.
Thanks, Jen. So what we've seen here is a very powerful story where we can author a web map, and this can be visualized in many different clients, be it mobile or desktop, or in a web JavaScript application. So let's move on to looking at graphics overlays next. The graphics overlays are typically used for displaying temporary or fast-moving items. So temporary information could be just some markup that you're drawing on your map, but fast-moving items could be coming, say, from a radio feed. So maybe you've got the location of taxis moving around a city and you want to be able to draw those on the screen very quickly. Now they can be used for displaying points, lines or polygon data, and they can be rendered in exactly the same way as your feature layers. So the symbols and the renderers that you're familiar with can all be used in graphics overlays. Now it's worth noting that graphics overlays are part of the map view or the scene view. They're not part of the map and the scene, and the reason for this is they're not persisted. So a map which contains a base map and operational layers can be saved in ArcGIS Online. Graphics overlays are just temporary information. They're in-memory information that you were responsible for maintaining the contents of. Now in terms of draw order, when you're rendering things on the map or the scene, your base map will be drawn at the bottom, and then on top of that you draw your operational layers, and then on top of everything else goes your graphics overlays. So as I've already mentioned, graphics overlays are found inside the map view or the scene view, and each can have multiple graphics overlays. Now the graphics overlay is effectively a container for your individual graphics, and you can define a graphic as having a geometry, point, line or a polygon, which you can see on the screen. Optionally it can have attributes associated with it, so text that may describe it. And then of course you've got your symbology that defines what it looks like, whether it's a green line or a blue line, for example. Now, graphics overlays are very good for rapidly updating pictures, so potentially you can have many thousands of graphics all updating multiple times a second and still have a very responsive display. So to demonstrate this, I'm going to hand you over now to Jen, who's got a demonstration of graphics overlays.
Thanks, Mark. I have an application running here, and what you can see is a map with a familiar location symbol, which is a moving simulated location data source. And following that around, you can see a trail of points indicated by the red circles here on the map. They are tracking the history of the location, and I'm going to demonstrate how these are being created and stored in a graphics overlay. So just going into the code here, we have an ArcGIS map being set to a map view, as Simone showed us earlier on. And we then have a graphics overlay being created and set to the map view. At this point, the graphics overlay is empty, but it's now ready to have graphics added to it. So firstly, we set up the red circle symbol that we saw on the map, which is an instance of a simple marker symbol. And we set the style here, the color, and also a size. Then we create a renderer using this symbol style and set this to the graphics overlay. Applying a renderer to the graphics overlay in this way is a less resource-intensive way than applying the style to each individual graphic. And instead, any graphic that's added to the graphics overlay will use the same style. So we now need to actually track the history of the location data and create points as we go along. So to do this, we're using a location changed listener and tracking location changed events. So each time the location of that larger blue marker we saw earlier changes, we need to create one of the red circle markers. So firstly, we grab the latest position, which is an instance of a point, which is a type of geometry as part of the API. We then create a new graphic and set the geometry of it to the position. Our graphic is then added to the graphics overlay, and remember that the red circle style is automatically applied here because we set a renderer on the graphics overlay itself. So if I just click back to the application, we can remind ourselves of what we see. So we have the graphics here tracking the history of the simulated data location. So this demonstration was based off a modified version of the show location history sample, and that's in our Java samples repository. So again, you can go and access that on GitHub and explore further if you wish. I'll now hand back to Mark.
So next I want to give a short introduction to the offline data workflows in runtime. So all the demonstrations we've been looking at so far, the data we've been adding into our applications have come from server sources. So we've seen data sources coming from feature services or entire web maps added in. You could actually go a little bit further and add in some data editing workflows into your applications. Now, very often these applications are used out in the field for data collection. So if you travel for a very long time to do an ecological data survey, for example, it's going to be a very disappointing experience if you get there and find you've got no network connectivity. Now, Runtime has made a big investment in offline data workflows to enable you to be able to edit and view data without any network connection. Now, we support this in one of two patterns, the most common of which is the services pattern. This is where your data resides inside of a web map or your own portal for ArcGIS. And if you've configured this correctly, what you can do is you can make a request to the server to take a portion of the data offline. So this will be the area where you want to go out and do your field data collection. So the server will create you a package of data in the form of a mobile map package that you can download onto your device. And once you've got that device, you can view and edit the data without any network connectivity. Now at the end of the day, when you've got your network connection back, you can synchronize changes that you've made back up to your web map. Now this synchronization process is a two-way operation. So not only are you uploading the changes that you've made to the data whilst you've been offline, if somebody else has been editing the same data, it'll also download the changes they've made. So the end result is a completely up-to-date mobile map package which is ready for another day's worth of data collection. Now the second pattern we support is what's known as the desktop pattern. So this is where you can prepare data using ArcGIS Desktop, or more commonly ArcGIS Pro nowadays, to create a mobile map package that you can sideload onto the device that you're looking at your data. However, this is just a read-only pattern. You can't update the data in this pattern. Okay, so to complete our application development story here, I'm going to finish up by talking about licensing and deployment of your application. Let's just start off with licensing. So you've seen in the demonstrations we've made so far, there's been a watermark in one of the corners of the map to say it's licensed for developer use only. So this is an indication that this application is not ready for deployment, so we do need to license it first. So what you need to do is choose one of the different licensing levels we have in Runtime. There's Light, Basic, Standard and Advanced. Light is a free to deploy version of the SDK, and there's increasing levels of cost associated with Basic, Standard and Advanced. So if you go and take a look at our website, there's a link here, you can see what levels of functionality are associated with those license levels. Now in this talk I'm only going to be talking about the techniques for licensing your application from a coding point of view. Now there are two methods you can use, the first of which is what we call named user. So if you're already a subscriber to ArcGIS Online, you can just simply log into ArcGIS Online and that will license your application for you. Now we recognize that not everybody is a subscriber to this platform. Maybe you're just using OGC formats, for example. So if this is the case, then there is another method called a license code, which is where you will go to customer services or your local distributor to buy distribution packs of license keys that you can include in your application. Let's go and take a look at this from a coding point of view. So you've got your license code from customer services or your local distributor, and what you do very early on in your application before you touch any of the runtime functionality, so you can see here I've got this as the first method in my main start class, I'm going to call the setLicense method of the ArcGIS Runtime environment, and then pass in the string that will license my application. And I'm doing this before I'm even launching my JavaFX application. Now let's go and take a look at named user licensing. So this is when you log into your portal to get your ArcGIS license key. So I'm going to start off here by creating a credential to log into my portal. But I would say this code here is just for demonstration purposes. It's exceedingly bad practice to burn in username and passwords into your own application. What you would do here ideally is write an OAuth authentication workflow, but this is just for demonstration. Now next I'm going to connect to my portal that contains my data, and I'm going to pass in my credentials, and then I'm going to initiate the communications with the server and wait for it to come back. Now I'm doing this asynchronously, so I'm not blocking the UI thread in my application, and as soon as I've got this back, I'm going to check the load status to make sure that it was successful, it's loaded and not failed to load, and at that point I can go and fetch the license info, and once I've got that license info I can pass the license info into the setLicense method of my ArcGIS Runtime environment class, and then I'm good to go. Now you might be forgiven for thinking there's a little bit of a flaw here, because earlier on I was talking about offline workflows. So maybe you're thinking, how on earth is this going to work if I don't have any network connection? I've got to use the network to log into my portal. Well, don't worry, we have thought about this. So what you can do now to enable this application to work successfully for the next 30 days without any network connection is you can take that license info and serialize it to a JSON string and save that to a location on your hard disk. And that is good for the next 30 days. So if you're starting your application up and you don't have any network connectivity, all you've got to do is reserialize the license info from the JSON that we've stored on the hard disk, and then I can pass this into my setLicense method of my ArcGIS Runtime environment, so I can start my application up successfully without any network connection. Okay, so now we've successfully licensed our application, we're now ready to deploy it to our customers' machines. So typically the workflow you would go through here is you would write an application in your IDE of choice, which may be IntelliJ, Eclipse or NetBeans even, and you would test and hopefully compile that application into a jar file, which can then be deployed onto Windows, Linux or Mac. And that application runs as you'd expect with a Java application inside the JRE, the Java Runtime environment for that platform. Now you have to remember that runtime for Java is not a pure Java application. A lot of the functionality inside of the SDK is actually written in C++. So to make this work on your chosen platform, you need to include the appropriate library for the platform that you're deploying to. So on Windows, there's a DLL file that you need to include. For Linux, there's an SO, or if you're deploying to Mac, there's a dilib file. So to demonstrate this, I'm now going to hand you over to Simone.
Thanks, Mark. We have an application that we've deployed earlier and now can be run as a jar file. If we take a look at the directory structure here, within the JNI libs folder, we have our core runtime libraries for the different operating systems that are supported, including the libraries for the machine I'm using on Windows 64. So these are the core libraries that I will need to be able to run my jar. And if we go back here, we can now run our application. And now I'll pass it back to Mark, who will demonstrate how to run our deployed app on his operating system.
Thanks, Simone. So here we have exactly the same application that's built and running on a Mac platform. We have the same data, and if we go and take a look at the deployment folder that I'm working with here, the reason this is working effectively on my Mac platform is that it's picking up the runtime core libraries from the OSX64 directory, which is what you would need to deploy for a Mac platform. Or indeed, if I wanted to deploy this so that it's working on a Linux platform, I'd have to include the LX64 directory for that deployment. So here we've seen how you can deploy runtime applications that work across different platforms. So this brings us to the end of our session, where we've looked at writing cross-platform Java 11 JavaFX desktop applications. We've introduced you to some of the key classes and the techniques for writing your own mapping applications. We've talked about graphics overlays, introduced the concepts of writing offline mapping applications, and concluded by showing you how to license and deploy your application. We hope you've enjoyed this session and it gets you going with writing your own JavaFX runtime applications. Thank you. Okay, so good morning, and thank you very much for listening in to our presentation there. I want to move on now to the live Q&A part of our presentation. But before I move on to answering the questions that you've posted, I've got a number of questions coming in from different sources. I just wanted to thank everybody who has responded to the live poll there. This is always really good information for me to get a feel for how people are using the product and what platforms that you're writing your software on and developing to it. In the absence of face-to-face meetings, this is all very good information to get from you. So I'm going to move on to some questions that we've got coming in. And the first one is from somebody who's asking about how we are keeping up with new functionality which has been introduced into the JavaScript API, and roughly the timeline that we'll be adding in those capabilities into the runtime SDK for Java. So I'm going to answer this really for all of runtime SDKs. So I would say that we have a release cadence of 4 months, and what we aim to do every time we release is to keep up with the latest capabilities which are being delivered as part of all of the ArcGIS platform, of which Runtime, Java, .NET, Qt, on the other platform, and the other sort of APIs that we have will all release exactly the same capabilities. And we will usually, within sort of a 4 to 8 month cycle, keep up with the capabilities of all of the runtime clients. And we've got another question coming in here. So this is around what rendering capabilities that we have, or sorry, what sort of rendering technology we use inside the Runtime SDK. And for that, would Jen or Simone like to answer that one?
Yeah, the rendering technology we use in the background depends on the platform you are running it on. If you're using Windows, we render using DirectX, and for Mac and Linux, we use OpenGL.
Okay, thanks, Simone. So just to add to that, one thing that we are going to be making a change to in a sort of a future release, this is probably by the end of the year, is that we'll be supporting metal rendering on the Mac platforms. And this is because Apple are no longer actively developing their support for the OpenGL drivers. So we will be moving to metal probably around about similar sort of time that Java 17 is due out, which will be supported on that platform then. Okay, so the next question we have is there a plan to improve the scene view 3D capabilities of the graphics overlay renderer so they catch up with the functionalities available with feature layers dictionary renderer in terms of dynamic rendering? Now, the person who's posted this, I have sort of posted a reply with my email address, so do sort of contact me with some more specific details. But at a high level, I would say there is very little difference between the two. So if you're able to render something as a feature layer using a dictionary renderer in 3D, you should be able to do pretty much exactly the same in a graphics overlay, because we use exactly the same rendering pipeline for drawing the two things on the screen. So in the background, it's actually using the same code. So if you're not able to display something using graphics overlays, then I'd be quite interested to hear about that, and we'll see if we can sort that problem out for you. Maybe a workaround. Okay, we've got another question coming in about the use of different JVMs. Somebody's asking here if they can use an Oracle JVM, for example. I don't know, would one of my co-presenters like to have a go at answering that one?
Yep, I can answer that one.
Thank you.
The short answer is yes. Oracle JVM is supported. For our current release, which is 100.10, we support the use of the Oracle JDK, Open JDK, and also the Adopt Open JDK, which is the one that we use in our own development environment. But just to note that this is for Java 11 only. We no longer support Java 8.
Thanks, Jen. So yes, Java 11 at the moment, and we will be aiming to support Java 17 in a release post-September. We'll probably be recompiling the product to work with Java 17 then, because we do aim to support some changes for Apple developers. So we've got, we want to be able to support metal rendering, as I've already sort of pointed out, but we also have new Macs coming out, which have got the M1 processors. So these are the ARM processors. So again, we'll be migrating to Java 17 so that we can support this ARM chipset architecture. But again, on all three JDKs. So thank you, Jen. And we've got another question coming in here about the listener for the graphics overlay sample, and is that for using geo event like in the JavaScript API? So I would say at the moment in runtime we don't support stream layers coming in from the geo event server, but that is something that we're looking to support in a future release. So that should be coming in the next 1 or 2 releases. I have seen the backlog items for that. And then we've got questions still coming in. So there's one here coming in. Oh, about probably the comment that I made about it being bad practice for including username and passwords in your code base. And somebody here has asked the question: could I use a property file so that I could obtain license info from the portal? The answer is yes. I mean, you can do either. So the only reason I say it's bad practice to put this into your code is that there is the potential that somebody could reverse engineer the bytecode that gets created from your application and be able to extract your password. So wherever you store it, you just need to be mindful of the fact that somebody could get a hold of that. You might want to consider encrypting it in some way, for example. Okay, so what other questions do we have? Yeah, we've got a question coming in here from Eric Bader. Actually, I know that person, and he's asking a question: do we plan to support 32-bit Linux going forward? So the short answer to that is that we have deprecated the support of 32-bit Linux. We don't have a lot of demand for that at the moment, but if you've got a good business case to bring that back in, that's something we could certainly support. So yes, Eric, I think you've probably got my email address. If you've got a specific requirement for that, then let me know. And just looking here, we've got a question about Linux. That's a question which I will, from Jim, I will try to answer that one separately, actually. So I'll sort of contact you directly. Okay, so the question is around about, do we need to identify the platform that we're sort of deploying to? So the user here is actually making use of Windows sometimes and Linux sometimes. So in terms of deploying applications to different sort of platforms, I would say the Java ecosystem is changing very slightly, and traditionally people would have created jar files. I think they're sort of known as fat jar files, that you could potentially have them so that they run on any platform that you want to make them work on. So that could be Windows, Linux, or Mac. Probably what you'll find in the future is that we will find that Java deployments will be mainly aimed at individual platforms. So you'll have individual deployments for specifically Windows, specifically for Linux, and specifically for Mac. And you'll certainly see this in things like JPackage, which is going to be coming out of future versions of the JDK, that enables you to be able to create installers for Java applications which are natively designed for the platform that you're going to. So it could be a DMG for Mac, or it could be an executable for installing that on a Windows platform. And this is very much in line with how JavaFX is starting to deploy now. So you can use either method for deploying your applications, but I think you'll start to see more people starting to use platform-specific installers. Okay, so I think for the moment we've run out of questions there. So what I would like to do is bring this session to an end, and I would like to thank everybody who's sort of asked questions. If you do have any questions that you feel that you didn't manage to get in, or I didn't answer them in a sort of a sufficient detail, I would like to say that if you go to the Ask an Expert session of the conference, I and sort of a few other colleagues from the runtime team will be there. So there's a runtime specific section where you can go and ask us any questions. So with that, I would thank you all for coming along, and I hope you enjoy the rest of the presentations. Thank you.